Alaikum. As you all know that we have already started the unit called as magnetic effects of electric current, and today in this offline lecture I will be going through the textbook questions that are being present on the textbook. And let me start from the first question. It is on the textbook at page number 61, and the question is, why does a compass needle get deflected when brought near a bar magnet? Again I will repeat, why does a compass needle get deflected when brought near a bar magnet? The answer for this is simple, that in case of a compass needle, it is already made of a magnet. Compass needle, I will say, compass needle is magnetic in character, is magnetic in nature, I will say, is magnetic in nature, and the nature of the compass needle is magnetic. So when brought close to a bar magnet, or when a bar magnet is brought close to a compass needle, it deflects. Because we already know that like poles, I will say magnetic poles, like magnetic poles repel, and unlike magnetic poles attract, and unlike magnetic poles attract. It simply follows that principle due to which we can simply say that a compass needle when brought close to a bar magnet, or a bar magnet brought close to a compass needle, deflects the compass needle. The reason is that the compass needle is magnetic in nature, and when two magnets are brought close to each other, you can simply assume that there is either attraction or repulsion, because if the north pole of the bar magnet is brought close to the compass needle facing the north, then it will repel, and vice versa. The second question is page number 65. Page 65. The question is, first is, draw magnetic lines around a bar magnet. For that, I will, inshallah, when the school will reopen, I will show you in the practical lab how we are going to draw the bar magnet. We are going to draw the magnetic field lines around a bar magnet by using a compass here. But the second question here is, it is list the properties of magnetic lines of force. Properties of magnetic lines of force. You will simply say, we have already gone through this topic as well. What are the properties of magnetic lines of force? You simply should remember that the magnetic lines are closed curves. The magnetic lines are closed curves which move from, you already know that they move from North Pole to South Pole. North Pole to South Pole outside a magnet. And from South Pole to North Pole, and from South Pole to North Pole inside a magnet. Second property is that two magnetic field lines, or magnetic lines of force, cannot intersect each other. Third is the tangent. The tangent at any point to a magnetic field line to a magnetic field line gives direction of magnetic field line at that point, gives direction of magnetic field at that point, gives direction of magnetic field B at that point. These are the three simple properties with regard to a magnetic, Now the third question at page number 65 is that why two magnetic lines of force cannot intersect each other, or why two magnetic lines of force never intersect each other? The simple answer is that at the point of intersection, there are two tangents. Pointing in two directions, pointing in two different directions, which is not possible. Because magnetic field at a given point can have a magnitude but only one direction. Here we are saying that there are two different directions, and which is not possible. So with this I conclude the questions of this page number 65, and we will study the other questions in the next offline lecture. Thank you.